Can you believe it? Here we are, the last two sections of geometry. 11.7b, surface area of prisms and cylinders. The next one after this is going to be 11.7c, surface area of pyramids and cones. So why are we looking at prisms and cylinders, first of all? Well, because both prisms and cylinders, as you will remember, both of them have two bases. So those are the easiest ones for us to do. And we have looked at volume of these solids, but now we're looking at surface areas of these solids. You will remember that a prism is a polyhedron with two bases, like we just said. And here's some new terminology for us, though. Lateral faces. Lateral has the idea of like a lateral pass in football. You're passing it to the side. So these are, see, up on top and bottom, these are our bases in this particular prism. Over here, top and bottom are also our bases. And you will remember that in order to be bases, they have to be parallel and congruent. And then the faces around are your lateral faces. And those are the remaining side faces. The altitude of the prism is a perpendicular segment that joins the planes of the bases. So here, these look like right prisms, meaning this is a right angle from the base to this edge. And so this would be your altitude, this segment. But when you have an oblique, oblique means it's squished off to the side like that, then this side would not be your altitude, but instead it needs to be this perpendicular segment, where that is perpendicular from the base up to the other base. We might say perpendicular between the bases. So you could have the altitude going like this, as long as it's parallel to these two. Okay, and I'm sorry, no, I said that correctly. So altitude, and so the altitude is the segment, and then the length of that altitude is the height. So that's what they're saying here, that the length of the altitude is the height. So the altitude is the segment. Maybe you want to write that in there. So altitude is the segment, and the height is length. So height is a number, altitude is a shape. And like I mentioned, a right prism is when the lateral faces here are, or this edge is perpendicular to the base, and that will make all of the lateral faces rectangles. So each of the lateral faces around this right prism are rectangles, whereas an oblique prism, where it's squished over to the side, then some or all of the lateral faces are non-rectangular. So here's a parallelogram, and you can see that this is not 90 degrees here. That's an oblique prism. Okay, so that's our foundational terminology. Let's get to it now. A lateral area. So the surface area, that's this thing here, surface area, is the entire surface area. So here we have, in this case, it's a prism, and the surface area is the area all the way around this prism. And the surface area consists of the lateral area, the area around the sides, and the bases. So if you would pull out your Chapter 11 formula sheet, and you will see here for prisms and cylinders that our surface area, the one main formula from which we can build the specific formulas, the one main formula for the surface area of prisms and cylinders is lateral area, that's their side area, plus 2 times the area of the base. So because prisms and cylinders have 2 bases, therefore you multiply the area of the base times 2. Just in contrast, let me show this to you real quick, that when we do pyramids and cones, there's only one base. So the same lateral area, it's calculated differently, but still it's the lateral area, and plus one base, because in both a pyramid and a cone there is only one base. So let's try to understand that a little bit better. So here's your prism as it's normally folded up, and you can unfold that prism, and this area here, now here it is all the way flattened out. This area here is your lateral area. In fact, I guess we could go ahead and write that there. So let's write lateral area. And these here are your bases. So capital B, the area of the base. So let's see if this shows up in the video that well. Here's your three-dimensional prism, and just like a box of cereal, I can unfold this guy, and you'll see that here are your two bases. Those are your two parallel and congruent bases, and those are on top there. And then these are, this entire thing consists of our lateral area. So to find the lateral area, how do you find that lateral area? You could add up each of these individual side edge lengths there, but it's easier to think of it as the perimeter. All it is just the perimeter around the base. So that's why, and if you would do this on yours also, make this a boulder, what is that, a polygon there, or a parallelogram in particular. Make that a nice big bold polygon, and then show how as you cut this edge there and unfold that, you get this shape, and then you have this entire, when it's all laid out like that. So let me show that to you again here on our model, that the distance, the perimeter around the base is the same distance of the length of this rectangle, which is your lateral area. So to find the area of this large rectangle, you would multiply the perimeter of the base times the height of your right prism. Okay. And so here's just another explanation of that, little fuller explanation if you want to read through that. And again, I just wanted to emphasize that the perimeter is the distance around that base. So let me show you two examples. This is not in our book. Larson, for whatever reason, our textbook does not talk about surface area, and it will be on the FSA, so we need to make sure to talk about it. This older book, though, does talk about it. So here is a prism, and if you were to unfold that, you would get this flat net, they call it. And notice it's different than, for example, like mine here. The only difference for that is that I could cut this off and then slide it and put it over here, and it would give me the same relative shape as you have here. So again, this is your lateral area, and notice that this length here, the length along here, 4 plus 3 plus 4 plus 3, is the same as the perimeter, or the length around the base. And so notice that these two threes, these are both 3, they connect together, and then 4, these would overlay. So like here, let's do it. If this was 4, actually kind of the way it's written here, this would be 4, this would be 3 and 4, and then add on another one to the right. But notice how these fold together. In this case, the 3s you'd talk about, and then the 4s connect together, and then here's another set of 3s. So either you can think of it as the length here of this lateral area, or the perimeter around the base. Those are equivalent distances to each other. And so the surface area is equal to the sum, or let's see, we would do, yeah, here. So here is your lateral area. These four rectangles are here, and then here are your two bases. Let me show that to you in a way that might be simpler for you to see. Here's another example in the book, a prism, a triangular prism. And so again, the key thing is to identify your bases that have to be parallel and congruent, and they're triangles, and then unfold this and make a net out of this three-dimensional object. And if you were to, then this is what you would get, my beautiful drawing here. And so here is my area of the base, and since I have two area of the bases, my equation for the surface area is going to be lateral area plus 2 times the area of the base. And notice that this side, this edge here, is the same as this other edge. These are both 5, and then these two edges are both 3, because those are going to connect together, kind of like in this shape. If I was to connect these together, you see how these are the same length. I guess it'd be like this here. So here's your lateral area going across, and connect these together, and those would be having the same length. So my equation that I'm going to use, since it's a prism, is surface area equals lateral area plus 2 times the base. And let's find these separately. So the lateral area, to find the lateral area, I multiply the base, in this case, this base, or you could think of it as the perimeter around the triangle. Probably a better way of thinking about it would be 3 plus 4 plus 5. And there's my this length of this rectangle, and then times 6, which is the height of that rectangle. So this number, multiplying these guys, gives me 72. So this area, this lateral area, is all 72. And then I need to add that to 2 times the area of the base. Let's figure out the area of this base. And since this is a right triangle, my base, I can consider that to be 4 here, and my height is 3. As you remember, the area of a triangle is 1/2 base times height. So plugging those numbers in, the area of the base equals 6. So now let's put these pieces into our larger equation, and surface area of this entire triangular prism equals the lateral area. That's the center section here. We found that to be 72 plus 2. Remember, there's 2 bases in cylinders and in prisms. So 2 times the area of the base. And we calculated the area of the base to be 6. So therefore, in this particular case, our surface area is a grand total of 84. So break it down into parts, solve the individual parts, and add them together. So you are ready now. You are ready for the back of your notes. You'll see a nice simple problem here. So draw a net similar to what I had drawn. I can start you off here. Well, what you do is look at the base. Determine what your base is going to be, and draw that base, and identify that the lengths on your base. I would say this is going to be my base. You could choose either the right and left sides or the front and back sides if you wanted to, but it's probably easier just to identify the top and bottom as the base. And so here, this guy's 5 and this other one is 6. So now let's extend this. I'm looking for the lateral area now. Let's extend this out. And what is the length of this? Make it a little bit smaller. What is the length of this this edge going to be? It's going to be the same as the length here, because these, when they fold together, are going to touch. So this is going to be 6. And then what is the length of the next rectangle? I gotta go ahead and close this one up. I'm going around here, so this surface on top is going to touch this one over here, so that's going to be 5. And then I like doing it over here because it's easier to see how these connect together. And since this is a rectangle, this side over here is going to be 6. And since these two will fold up together, this one's going to be 6 over here. And of course this is a prism, so I want to add another base on the bottom. And what am I missing? I'm missing the height now of my prism, so the height is 8. There you go. So now write out your surface area equals lateral area plus 2 times base. Figure out your lateral area, which is going to be your perimeter, the distance around this, which in this case is what? That's 12, so it's 22 is the total distance around. And if you were to add these numbers up, you would also get 22. So 22 times 8 is going to be your lateral area, and plus 2 times the base. And this is your area of the base. Here's another area of the base. So it would be 5 times 6, which is 30. So 30 and 30, and then add that to the area, your lateral area here, and that would give you your surface area. How's that for a hint? That should help you. Okay, so go ahead and pause the video and do that problem. Now we're doing cylinders, and you know what? I don't need the book yet. Let's just go straight off of the notes. Yep, let's go straight off the notes. So what is a cylinder? Let's remind ourselves that a cylinder is a solid that has circles as its 2 bases. And those 2 bases, of course, are congruent and parallel in order to be bases. And the altitude, just like we had said before, for a prism, the altitude of a cylinder is a perpendicular segment that joins the planes of the bases. So if it is a right cylinder, like this one is, it appears to be, then it would be this edge here is an altitude. If you have an oblique cylinder, it's pushed over to the side, then you'll have to create an altitude. This segment, this dashed segment out here, is going a perpendicular distance between the 2 bases. I might even want to come down like here, and this would also be an altitude going up and down there. So there's different places where you can draw your altitude. And then the height is the length of that altitude. Okay, so let's think about a cylinder. How do we figure out the surface area of a cylinder? Well, as you know, you can cut it down the edge and then around the bases and then unroll that cylinder. So I think this is a little bit big for our video purposes, but you see here that I have a cylinder, and if I was to slice it down the side and then around the tops, I can unfold. So it's kind of like a can now, right? So I have a tin can with a lid flipped off, and then I can do the same thing with the bottom and flip the bottom lid off, and then I can slice it down the side and then unroll this. So you see here I have one large rectangle and then 2 circles that are my bases. So that's what they're representing here. A large rectangle and then my 2 bases. So therefore, let's go ahead and switch over now to your formula sheet. And, well, no, let's not do that. Well, I guess we could, now that I'm already here. So notice that 2 times the area of the base, and the area of the base is pi r squared. So the area of the base is for a circle is pi r squared, and then you multiply that times 2. And, well, I'll tell you what, I should have emphasized this. Notice that, here's the question, how do you figure out the length? How do you figure out this length of this lateral area? Well, notice that the length of the lateral area is the circumference of the circle. When I unfolded this, well, when I fold it back up, that length of the surface area goes all the way around the circle. So the length of the surface area, the lateral area, length of the lateral area, is the circumference. And so I probably should have done that. I forgot to do it. I should have made that. Here it is. Good. So let's do that. Let's make this circumference around here first, and then circumference, but then also draw that in on yours, if you would, to my marker's dying. Alright, so hopefully your marker's working better than mine is. This one's going in the trash. And notice that this length of the lateral area is the same distance around the circle, which is the circumference. And so that's why, a little faint on here, how about if you write it in yours, circumference equals 2 pi r. If you can't see, circumference here equals 2 pi r. So that length is the circumference around the circle. So that's why they say down here that the lateral area equals 2 pi r, that's your circumference, times the height. And the height is this distance up and down here. So that's easy for the lateral area. And then the area of the base, like I just said a moment ago, is pi r squared, 2 times pi r squared. So maybe put parentheses around these guys down here too. So the surface area equals, this is your length of the lateral area, 2 pi r, which is the circumference of the circle, times the height here, plus 2 times the area of the base. And the area of the base is pi r squared. So let me show you an example here, similar to the one that you will have in your book, and then we'll be done. Here's my net of a cylinder. All that they give me is the radius is 4 inches and the height is 6 inches. So I figure out what the length of this lateral area is by figuring out the circumference of the circle. Circumference equals 2 pi r. The radius of the circle is 4, so I plug that in. So therefore the circumference, this length here, is 8 pi. Just multiplying the 2 times the 4 gives me 8. So now that I have the circumference, I can plug that in for what you think of it as the base of this rectangle. The lateral area equals base times height. My base is 8 pi, and that's my circumference, times the height, which is 6 inches. So the lateral area, this area here, is 48 pi. We're going to leave that in terms of pi. It makes it easier for us. And the base, I have 2 bases, and they are the shape of circles. So the area of a circle is pi r squared. My radius is 4. Plug in 4 for radius. 4 squared is 16. So the area of the base is 16 pi. So now I have my pieces. I can put them together. And the surface area of a cylinder is lateral area plus 2 times the area of the base. There are 2 bases. So for lateral area, plug in 48 pi plus 2 times the area of the base is 16 pi. And therefore the surface area of this particular cylinder is 80 pi. Alright, I tried to make that short and brief, but hopefully it's also helpful to you. Look forward to seeing you soon.